Welcome to GCSE Mathematics, feedback on June 2015, Unit 5MB0. You will need the following items to hand: copies of the question papers, the Activity 1 document, if you wish to do Activity 1, Activity 1 responses, if you want to check your marking, the Activity 2 document, if you wish to do Activity 2, Activity 2 responses, if you want to check your responses. Delegates will receive feedback on national performance of candidates on Units 1, 2 and 3 of the June 2015 examination series, consider the variation of candidates' performance on different questions and possible reasons why, look at the examiner's reports, address common issues and FAQs. Student response. Candidates who did well on foundation tier, as well as getting most one-mark questions, they were correct on straightforward processes or processes involving money. For example, F1 question 5, carry out a multi-step but clear-cut problem. F1 question 11b, solve a problem involving percentage. F2 question 9, use of a word formula in a problem involving time. F2 question 14, solve a problem using a conversion graph. F3 question 20, draw a quadratic graph. On higher tier, as well as getting most one-mark questions, they were correct on straightforward processes or processes involving money. For example, H1 question 5, solve a problem involving percentage. H1 question 7c, solve a problem involving means of combined samples. H2 question 6, solve a problem involving rates and ratio. H2 question 8, solve a problem involving stepped percentage rates. H3 question 4, a best buy problem. H3 question 17, area of a pentagon. Paper F1 question 5. Although the mathematical techniques involved are basic, there is a lot to unpack in doing this question. This was a quality of written communication, QWC question, so full working has to be shown and a written full conclusion given. This response is well structured, correct, and with a clear conclusion. Not all candidates were able to analyze the information and decide on the appropriate calculations. In this case, the calculations are correct, but meaningless. This one is a better attempt, but the problem has not been fully addressed. Despite the previous two slides, students tended to perform well in this question. Most candidates showed an understanding of the structure of the question and were able to carry out the relevant arithmetical operations correctly. Performance could be improved by practice of questions in context. For example, Edexcel functional skills papers have many such examples. The next question is common to F and H tier. This is also a problem, and candidates have first to analyze, then translate it into suitable mathematical processes. These are: select Monday's cost, Find the reduced cost for Monday by doing 109 minus 15% of 109 or 85% of 109. Subtract that answer from 125. Here is an example of a well-structured response. Despite this being a calculator paper, the candidate has found the percentage reduction by decomposition, but the answer is correct. By contrast, this shows a naive response. There is no calculation shown for reducing 109 by 15%. As the remaining marks in the question are dependent on the candidate using a correct method, this response scores no marks. In summary, most candidates showed an understanding of how to find 15% of 109. Performance could be improved by encouraging the use of calculators in class to solve percentage problems. In H1 question 7c, the answer depends on the answer to 7b. This, of course, would be followed through in the mark scheme. For this response, the answer to part B is correct. The candidate has the correct idea of working with totals for the two groups. In this response, the candidate has been taught the key idea of using totals, but does not have a clear idea of what totals to use. The 25 in 66 plus 25 is the number of younger guides, and the origin of the 30 in the denominator is a mystery. It looks as if this candidate has tried to master a rule without fully understanding the rationale. In summary for question 7, students tended to perform well in finding the mode and, at H tier, the mean. Most candidates showed an understanding of finding the mean of a frequency table. Finding the mean of a combined could be improved by learning to work with totals and to understand the reasons behind the process. Paper F2 Question 9. This question assesses whether students can use a two-stage word formula and apply it to solve a problem. The stages in doing the question are: work out how many 0.5s in 2. Use the rule correctly to find a cooking time. Work out the start time. F2 is a non-calculator paper, so the numbers tend to be simple to deal with. This shows a fair attempt, as the working has been shown and all stages have been carried out. Typically, things have gone wrong with the use of the two-stage rule. In this response, the candidate shows working, can apply the formula correctly, but inexplicably converts 80 minutes into 1 hour 10 minutes. In summary, students tended to perform well in solving a problem involving several steps. Most candidates showed an understanding of using a two-stage word formula. However, not all could use it correctly. Performance can be improved by practice on questions in context. For example, Edexcel functional skills papers. Activity 1 is a marking exercise. Mark the examples in the Activity 1 document. You may want to compare your marks with the ones given in the Activity 1 responses document. Here is another question which raised some issues. It is a common question on F2 and H2. This was a multi-step problem in which the stages for solution were: find how many litres of mixture are used, then use the ratio to find how many litres of oil are used, then work out the number of bottles of oil, then work out the cost. This is nearly a fully correct answer. The error is the arithmetical one of 3,000 divided by 20 equals 1,500. And the candidate then makes no further errors. However, many candidates did not engage with the question, especially the ratio, and ended up with typically 1 out of 4 marks. Note on both slides the lack of completely accurate arithmetic. For this question, students did well who had a clear idea of all the stages needed in the solution of the problem, had the technical skills to carry out the calculations correctly on this non-calculator paper. Here is a question set at mid-demand on the higher paper. The stages in the solution were: find the missing top length of this compound shape. Write down expression for the areas of the 2 rectangles this shape can be split into. Expand brackets. Collect terms. So here is an example of a very good solution, which follows all the stages seen on the previous slide. This is a good attempt. It shows understanding the need to find a missing side and also the correct use of brackets to write down areas of rectangles. However, the 2 expressions written down are for areas of overlapping rectangles, so adding is not correct. In summary, successful candidates were able to visualize the correct splitting of the compound shape, were able to work out correct expressions for relevant missing sides, were able to write down and expand algebraic expressions for the areas of the relevant part. Lastly, here is the first of 3 questions from the paper 3s. The most efficient way of doing this foundation tier only question would be to work out 116 plus 86 equals 202. Work out 12 plus 9 equals 21, multiply 21 by 8, and then subtract the answer from 202. This was rare. Much more common was the step-by-step approach shown here. Despite this being an apparently straightforward problem, many candidates misunderstood how to go about solving it. Attempts which focused on bags usually went badly wrong. Consequently, For this problem, successful candidates were able to break the problem into its parts. That is, work on apples rather than bags of apples. The next question was common to both tiers. Candidates had to recognize and remember formulae for working out the circumference, given the diameter, and working out the third side of a right-angled triangle, given the other two. This solution shows a confident use of both formulae. This shows a partially correct attempt. The candidate has not learned the formulae sufficiently well, and so fails to score the final marks. For this question, many students tended to be poor on recalling formulae, showed a lack of awareness of the need to use Pythagoras. This could be improved by learning the formula for Pythagoras and the formulae for the circumference and area of a circle. Possible approaches to this question are raised in Activity 2. However, here is the most efficient approach. This is a far less efficient approach, using only right-angled trigonometry. In summary, students tended to do quite well or very badly, depending on whether they spotted the most efficient method or were competent at using right-angled trigonometry in isosceles triangles. This could be improved by further work on half AB sine C, traditionally done at the same time as the sine and cosine rules, but really not dependent on them. Use the Activity 2 file to investigate some features of 8 questions taken from the papers. Features are followed up in the Activity 2 responses file. Some common issues. Generally, a strong response on the paper 1s, the statistics papers. Relatively poor technical skills, manifested on the paper 2s by poor arithmetic, and on the paper 3s by lack of knowledge of standard formulae. A much better response to QWC questions, where candidates now show more working and tend to give a clear reply to the question. Finally, some information of where to find examination statistics and the wealth of data there is available from Edexcel. And a reminder of the current changes to GCSE and GCE. Also a reminder to contact us regarding this particular session.